Okay. The session is being recorded. Thank you. Good morning, good afternoon, and welcome to today's session on the API Connect Micro Gateway Deep Dive. We have several folks from the development team on here today to be able to present and deep dive for us. This is a long session, so we'll try to logically arrange times and pauses where we can ask questions. Using the meeting chat is a good way to get those questions out there. So folks can answer them kind of in line. But without further ado here, we'll go ahead and get started. So Tim, thanks for coming. The floor is yours.
Thank you. My name is Tim Smith, and I'm the overall lead of the Micro Gateway development team. This presentation is purely a chart deck presentation. Several members of the team several members of the development team will be presenting pieces that they were the experts on, that did the development for. So let me first off just kind of walk through the agenda, tell you a little bit about it. I'll go through at a high level and talk to the micro gateway, the components, a little bit of that. And then Libra Huang is going to take us through the design of the flow engine and the micro gateway in general, all of the different middleware components that comprise of the micro gateway. And then we're going to go into security for a bit. So Dan Bott will take us through the security overview. He'll also talk about client ID and client secret validation. Then John Balessa is going to take us through a couple of sections on security. One will be basic auth, and the other will be cores. We did have a slot for basic rate limiting and advanced rate limiting. That's not going to be in today's presentation. We'll set that aside for a second session, if you will. Then Ali Zhuang from our Type A team will present the invoke policy. She'll also present the sequential logic that you can use within the micro gateway. In particular, the flow engine allows you to use logical conditional constructs to determine what path your flow will take, and Ali will take us through some of those. Then Gary Tu will take us through the set variable policy. Yihong Wang is going to talk a little bit about basic analytics, what you get with the micro gateway. He'll also take us through a JavaScript policy. And then Thomas Burke will take us through something like a more advanced JavaScript policy called a user-defined policy. And Dan Bott will then again take us through logging and what is available there. And last but not least, I believe John Palgon will be presenting the data exchange between API management and the micro gateway. And the last session there for on-premise installation, Jeremy Geddes will not be presenting in this section. Again, we'll hold that off for a second session. Feel free to ask questions. I think we'll pause at specific spots, but I'm certainly fine with answering questions as we go. Everybody's on mute. You'll have to hit *1 if you wish to come off of mute. Okay, so I just wanted to make a couple of comments on this chart. This was one put together by the offering management team, in particular Arif Siddiqui. Laid it out, and I just wanted to talk to a little bit about the offerings and where the micro gateway fits in. So the Essentials offering is freely downloadable. It comprises or consists of essentially the NPM API Connect installation, which contains the micro gateway. But also there is an APIM component which must be obtained through the download site for Passport Advantage. But with the essentials, we talk about down at the bottom, kind of the secure. These are the policies that you get with the micro gateway. So there's obviously the proxying to a back-end API, if you will. You're only allowed one instance, but there are a collection of built-in policies. These are a subset of the policies that you would get with the Data Power appliance. So client ID and secret, basic auth, basic rate limiting, CORS, the invoke policy, set variable policy, and JavaScript invoke. Then moving over to the essentials, again moving over to the professional and staying within that secure row. It's basically the same level except that you're allowed multiple instances of the micro gateway. There also is the ability to use a Liberty Collective for deploying those instances. And also the rate limiting is more advanced in that it's shared between those two instances. So that's really where the micro gateway fits in within the offerings. So what is the micro gateway at a very high level? It's a node-based platform consisting of a collection of middleware components. So we really took the strong loop gateway infrastructure and basic design and added a considerable amount to it. We restructured it, added the flow engine so that you would have this architected processing of an assembly section of a Swagger document. It does consist of several pieces of middleware, one of which is the flow engine, and Libra will take us through some of the other middleware components. The micro gateway is really there for enforcement of the APIs. It consumes Swagger 2.0 API definitions. I guess there's a new version or a new name for Swagger, and I'm not sure of the name. I thought I had updated this chart, but I don't see it. The assembly portion is an IBM extension, so it is formally complies with the Swagger 2.0 specification, but it is an IBM-specific extension. Several versions of Node.js are supported, so 0.12, 4.x, and 5.x are all supported. And the operating systems, OS X, Windows, and Linux are the ones that are supported for the micro gateway. So if you're deploying a micro gateway, it's present in the API Connect OVA. I also mentioned it's also present in the NPM API Connect download, if you will. The Essentials says one instance, and what that means is one per API Connect install. You're allowed one provider organization, one developer organization, one catalog, and there's one gateway process per catalog. You don't get the application management on top of that. And as we mentioned, Professional allows two instances, so essentially two micro gateway processes. I see that's misspelled per catalog. And again, it does have some advanced rate limiting, which coordinates between the two instances. So,
Tim, yes. This is Mike. I got a question. So, you mentioned here that for the on-premise, the micro gateway is part of the API Connect OVA. So, does that mean, is that essentially the ability to be able to install the NPM package and pointing it to the management node once it's stood up? Is that what this is referring to, or?
That's a good question, and there are a couple of different ways of doing the install, and really I don't have all the information in this presentation, and Jeremy is really the expert at some of that. But essentially, the OVA contains everything necessary. You may want to get the NPM API Connect install in addition to the OVA, as it does a number of nice things for you, including setting up the development environment. But also, it's a pretty straightforward installation. When you're installing from the OVA, you have to copy files from some locations on the OVA into the system or environment that you wish to execute out of. But yes, it is contained in the OVA.
Yeah, because I don't know if that actually made GA or not. I don't know if we have some of the folks from HERZ, but we don't have to delay that now. But I just know that with GA, we actually had to install the micro gateway using the public NPM library or NPM repository and install it from there. I mean, in original documentation, it said it was actually part of that, but it's not. But we don't have to delay that now. But I just wanted to let you know that I don't think this top one made it to GA.
Okay. The other piece we touched upon is the NPM installation of the API Connect package. So just invoking that line, npm install -g of API Connect, will download off the internet the whole API Connect laptop experience and install it for you. Next up, I'm going to hand it over to Libra, and I think I'll continue to clip the charts. Libra, are you on by chance?
Yes, Tim, can you hear me fine?
Yes, I hear you well. Thank you, Libra. Go ahead.
Okay, so I'm going to introduce some of the major components in the micro gateway, and I guess it's important to understand what these underlying components do. So, you know, if there is any error on the gateway in terms of processing the request, you will have better idea when you see the log message indicating which part of the gateway has the problem. So, you know, bear with me. Let me go through the components that we have. So I guess we will just talk about the diagrams on the right-hand side. So as Tim just mentioned, the micro gateway is built on top of Node, Express, and the loopback framework. So all these components that you see in this diagram, they are all implemented using pure JavaScript. Okay. Two major components within the micro gateway. Right-hand side, the data store. Left-hand side, that's the gateway runtime. And what the data store do is really two things. Very first one, it periodically talk with the API management server and stay synchronized about, you know, all the API data, all the product data, all the, you know, plans data that user defined on the API management server. So that's it's very first important thing to do. Get the data from APIM and you know, store that in the data store. That's number one. And second thing that it does is it provides data services. It's a RESTful-based data services. So the left-hand side, the gateway runtime, when it has the needs, you need to figure out how do I process the incoming request. The left-hand side gateway component send the REST request to the data store. Hey, give me something specific about this API. So the left-hand side gateway runtime component can process the incoming API request accordingly. Okay, so that's the right-hand side data store. You talk with the APIM, get the API data, and then you provide a RESTful data services for the components in the left-hand side to query against the data. Okay, so that's switch to the components in the left-hand side. So the yellow boxes that you see over here, they are all Express middleware. So we leverage the Express middleware framework. We chain all these middlewares together sequentially. So when the incoming API request comes into the gateway, the request will be processed by the middleware one after another. Okay, so let me take you through what these middlewares do. Okay, so when the request comes in, the very first component that, you know, the request touch on is the UI or rewrite middleware. So what it does is to rewrite the incoming URL to make it not contain the organization and to catalog the short names in the URL. That's what the URL rewrite do. And then you pass the control to the context middleware. The context middleware, what it does is to create a context object, and that context object is a transaction-wide data object that can be stored, that can be used to store, transactional related information. For example, what's the request body, what's the API definition, so on and so forth. So that's like a big whiteboard where you can put information and also get information from. Okay, so that's the context middleware. It creates the context object. Then it passes the control to the analytic middleware. So the analytic middleware, what it does is it gathers the incoming transaction data and store the API usage information to the configured analytic server in the backend on the API management server side. That's the analytic. Then it passes control to the preflow. That's the most critical components that we have on the gateway. So what the preflow do is it look at the incoming API request data, including headers, URI, so on and so forth, and send a request to the data store, trying to find out what is the API that I should use to fulfill the incoming API request. Okay. If it finds the API definition that match the incoming request, it also performs the security check and also red limit enforcement. That's what the preflow middleware does. If the security check fine, red limit check fine, the preflow will pass the request to the next middleware, which is the assembly middleware. And the assembly middleware does is it look at the policy assembly definition that user defined on the API and UI. The flow chart, what's the first step, what's the first policy, what's the second policy, operation switch, so on and so forth. So what the assembly middleware does, it look at the policy assembly and ask you those policies defined by user. Then after that, the control will be passed to the post-flow and the error handler. So if everything goes fine, the post-flow middleware will send the request, the final process, the result, back to the API client. And if there was any error during the request processing, the error handler middleware will capture the error and send the error message back to the client. So that's the, how these components end-to-end work together to process the incoming API request and return to the client. All right? So, Tim, I guess we can, wait a second. So what I just described is the overall components that we have on the micro gateway, and you can see the policy assembly flow that we have over here. So as the very last bullet in the left-hand side, so when we ship the API Connect product, we have some out-of-the-box policies, like invoke, like set variable, and also it is possible for user to create the user-defined policies in the future. Tim, correct me if I'm wrong, but in the very first release, we are not yet providing the user-defined policy capability yet.
No, we are providing user-defined policies.
Okay.
As a beta, I should say, as a beta.
Okay. Okay. So I would later, in the later chart, I will talk about how do you write the user-defined policies. But this chart should give you some high-level idea of what are the components that we have on the micro gateway. So Tim, I guess we can go to the next slide.
I had a question on this slide.
Okay.
Sure.
This is Dinesh here. I see that there is a data store that is a component of the gateway. And my question is, if this is going to receive API requests, can we, with the data store in it, can we place this component in the DMZ? Or is it intended to be inside the private?
It's actually a part of the micro gateway. So the transaction is between the micro gateway and the API manager platform or server, if you will. So wherever the micro gateway resides is where your data store is going to reside.
Yeah, but if you look at the best practices, what we usually do is we never post anything. We never put anything, be it a system or a user database components that contain embedded databases. We never put them in the DMZ. My question is more architectural than I just wanted to think, was this intended to be deployed on the DMZ, or would we need to have some kind of a DMZ component that receives the request and then forwards it to the micro gateway?
I looked at this as equivalent to a data power platform with regard to that question. When we say data store, it's true that it's holding information, but it could be looked at just as an on-box cache of the artifacts that are present in the API management server, just as data power caches information, right? So yeah, I look at the micro gateway as belonging in the DMZ as well. I'm certainly open. Libra, do you have any other thoughts?
Yeah, I think the data store here is like, how data power caching the data in its storage. But in the other hand, data power has some security enforcement done on the box itself, so it's more resilient to the security attacktion. So we can put that in the DMZ.
Yeah.
Okay. So,
can you share your thoughts on concerns?
No. So the concern is if you tell me that this is a security hardened OVA, then I'm more comfortable. But in places, for example, let's look at the portal server. The portal server contains a database that it works with, and there have been clients who position this in the DMZ, and I had to put it back into the private and secure. I'm just wondering whether we have the same situation. If it's a DMZ hardened component, then it is worthy of being in the DMZ. But if not, then we need to look at whether it would be right to put it. Because the reason I'm asking is with customers, the security teams ask me, before you put anything in the DMZ, what are the components inside? This happened with one of my customers where they said that, can you have the portal server, the portal engine in the DMZ, and the web-facing component of that portal server in the DMZ? We need to separate that out. So this is the question that we're going to get on the field.
You make some good points, and clearly it's not as hardened as data power is. And it is shipped in source code form, so that source code can be looked at. I wouldn't get so caught up with the data store component itself, but I think the general question of does the micro gateway fit in the DMZ or should it be behind the DMZ is what you're asking, and I think that depends on the security profile that the person is holding or comfortable with. I suspect after listening to your argument, some people would definitely prefer this to be behind the DMZ, protected by the DMZ.
And Tim, can I add some more comments about
Sure.
the data store?
Sure.
I guess traditionally people have concern about the data store is it may contain some, say, user data, transactional data, but the data store in this picture is now, it doesn't really contain any user registry information, password, things like that. It contains the API definition, like URL pattern. So there is a slight differences over there, but I guess you make a good point. There are some security concerns there that needs to be considered.
Right, and that's a point-in-time statement, Libra. You know, that data store may end up containing key material in the future.
All right, good question. I don't think we have a crisp answer, but let me jot it down, and we do need to think about it and chat with our offering management guys and get a solution. Anything else, Dinesh?
No. In the interest of time, let's move on. Yeah, I'm happy to work with you offline if we need to discuss this more from a field point of view.
All right. Good question. Thank you, Dinesh.
All right, Tim. So let me continue. So we are going to talk about the policies a little bit more. So in the middle box, the blue little boxes in the middle in the policies assembly flow, you see each box represents a policy, and this policy, they can really be out-of-the-box policies provided by IBM or user-defined policies. And Tim, can you go to the next two slides? We can skip the next one because these are the middleware description, and I just talked through them, so we won't talk through them again. Let's go to the next slide. All right. So when we talk about policy, we need to talk about the flow engine. So the flow engine is a Node.js module. We use that to ask you a series of tasks, and it can also support like conditional logic within the flow. So we can say, if something happened, then I want to do A. Otherwise, I want to do something else. It has that capability, and it also provides the API. Like what you see over here, we have proceed, fail, stop, subscribe, unsubscribe. It allows the task within the flow to interact with the flow engine. The task can tell the flow engine, hey, skip me or go to the next task, or ask you more tasks for me. So this is a very generic flow engine framework, and the way that we implement it, we want this component to be reusable in some other places. And the flow engine is just used as a component within the micro gateway. We use it to ask you the policies that user defined in the APIM. So, if you look at the micro gateway policies implementation, they are implemented according to the flow engine API. And Tim, let's go to the next slide, and I'm going to show an example of the policies implementation. Okay, so as I introduced earlier on, all this implementation on the micro gateway, they are JavaScript basis. So if you want to, write a policy, so it can be run on the micro gateway and the flow engine component, this is the function that you need to implement. So you define the function. The function takes 3 parameters: properties, context, and the flow. Properties, they are really the configured information related to this specific policy or this specific task. Okay, in context, we talk about that in the earlier component diagram. So when a transaction goes through the gateway, the context will hold, the intermediate data in this context, and you can, get the information from the context. And flow is really the flow engine component. So what you can see over here is that you can get the logger from the flow object and log a message. Then you can do your own business logic over here. You can get some data from the context, do some processing, put your processing result into the context. And you can also do some subscription to the flow. You can tell the flow engine that, hey, flow engine, call me when the flow execution is done. So there could be some finalizing task that can be performed by the task. So, we make these APIs available to user. So if user want to implement the custom policy, they can follow the API and do their custom implementation work about the policy. Okay. So that's the flow engine. Tim, can we go to the next slide? So this slide we talk about the context variables that we have on the micro gateway. So for those of you who are already familiar with, earlier version of API and like version 4, a lot of these context variables are not new to you. There are a couple context variables newly introduced in version 5, and let me highlight them. Sorry, I didn't highlight the color before. So very first one is the API.document. So this context variable really contains the API's regular definition. So if you go to the API Connect UI, you can define the path, define the operations, define the assembly flow, and all of those, they are described in the API's regular. Okay, and that regular information is available within the API.document context variable. So that's something new in version 5. And another big piece is are the message.star variables that you can see in the right-hand side, the very last 4 context variables, including message.body, message.header, message.status call, message.status reason. So the message.body is really the payload that is going to be returned to the API client. So, during the policy processing, each and every policy, they may or may not update the content within the message.body context variable. And at the end, our post-flow middleware is going to flush the content within message.body, message.header, message.status call and reason, flush the information back to the client. Okay? So that's something new in version 5. Let's go to the next slide.
A question about these context variables here. Yeah, so Dennis has posted that, and this is the same question I came up with. Are these context variables consistent between the micro gateway and the data power gateway?
Yes, so that is the intention. So data power gateway also has the message.body, message.header, status call, and reason. So the answer is yes. If there's an inconsistency, then we need to fix that.
Okay, thanks.
All right, Tim, let's go to the next slide. Okay, and I think variables on this slide, they are pretty much the same as what we had before, except the request.parameters.name. So in the Swagger, you can actually define the parameters associated with an API. The parameter could reside in header, in path, in curve parameter. And if you want to access those API parameter value, you can access them through request.parameters.name. Right? So that's something new in version 5. I believe all these context description, they are available in the Knowledge Center. I'm going to take my words back. There are 2 specific context variables. The implementation is different between data power and micro gateway. Those two variables are system.date. Let me check. Just 1 second. I think it's system.date and the system.time. So in data power, the system.date is a string. System.time is also a string, but on micro gateway, system.date and the system.time, they are JSON objects. So it's a JSON object, contains the year, month, day, information, hours, time, seconds, things like that. But on data power, they provide the string. That's the only 2 differences between the data power and the micro gateway in terms of the context variables. Okay. Okay, so Tim, let's go to the next slide. Okay, so in version 5, for micro gateway, there are some internal variables. They are also stored in the context. And we store these internal variables into the context in order to gain better performance, because we need to, there are some metadata, we are going to use that for many times during the middleware chain. And we don't want to, query the data store to ask the same information for multiple times. So we store some internal variables in the context. And the naming convention that we have over there is to put them in underscore dot something, for example, underscore dot API dot parameters. Okay? And these internal variables, they are not documented, and they might be changed in the future, so they should not be used by the customers. Okay?
Just a question there, Libra. So you're talking about this because somebody with a debugger, for example, could see these variables. Is that correct?
Right. Right. That's correct.
Okay.
Thanks, Tim, for the question. Okay, Tim, let's go to the next slide. So we have so many information in the context variable. How do you access those context variables from API? There are two ways to access them, and again, the way to access the context variable is the same between data power and the micro gateway. So the first way to access that is to access the context variable in the policy assembly flow in the UI. So on API UI, you drag and drop an invoke policy to the flow, and you want to access a specific context variable. In this example, what you see over here is target URL. What you need to do is to put the $sign and parentheses in front of that variable name. Okay, that's how you do that. That's how you do it if you want to access a context variable on the UI. And on micro gateway, it has a JavaScript policy. You can write JavaScript code snippet and then the micro gateway to run the JavaScript snippet for you. And the way that you access that within the JavaScript is simply use the variable name or using the getter method. Okay, so in this example, you can see that we set the target URL to https://w3.ibm.com, and you can also use the set method. And line 4, line 5 on the right-hand side, you can see the access to the context variable directory or using the getter method. That's two ways to access the context variables. Okay, so Tim, I think that pretty much covers what I want to share with the audiences over here.
All right, good stuff, Libra. Thank you. Any questions for Libra on context variables or the overall structure of the micro gateway?
Yeah, if you have questions, go ahead and hit *1 and chime in. Going once? Okay. Go ahead and carry on. Thank you.
Thank you, Libra. Next up, I think we have Dan Bott. Dan, are you on?
I'm on.
Dan, go ahead.
Okay. You can control it if you want.
Okay.
All right. So I'm going to give an overview of how security works on the micro gateway, and then in particular the client ID and client secret aspects of that. If you're familiar with API management v4 or v5, this is probably going to look pretty familiar to you. It's probably about 95% the same. So I'm going to start out by giving an overview of how Swagger 2.0 security works. I'm going to talk about how the micro gateway implements that, and then I'm going to go over how the API designer allows you to configure it both in the design and the source view, and then I was going to talk about particularly some aspects of the client ID and client secret usage. Okay, next slide. So the micro gateway uses Swagger 2.0 for its security. As Libra just mentioned, it operates in the pre-flow component. So if you're familiar with Swagger 2.0 security, it basically defines three different types of objects. The first is known as a security definition, which declares security schemes that are available that you can use. Those are always at the API level. So basically, this is sort of your library or your palette of available security schemes that you can use later on in the security requirements. The security schemes, they're individual components within this security definitions, and they define the characteristics of the security definition. And then the third component is the actual security requirements. These are actually what get executed or enforced at runtime, and those are just things that are declared in the security definitions. So if you look on the right, I have an example of the YAML that would appear in the Swagger document. You can see in the pink, or the pink are the security definitions. There's two security schemes in there, one for the client ID header and one for the secret. And then below in the blue is the actual security requirements, and those are the things that get executed. And those are just basically the names of the security schemes. So Swagger also defines three types of security schemes. API key, there's two types of those. There's header values in the URL header, and also, in the request header, and then there's query parameters in the URL. The example on the right uses headers, and the second kind of security scheme is basic authentication, which is username and password. The third type is OAuth, and there's four types that Swagger defines: implicit, password, application, and access code. So next slide. So I'm going to describe here how the micro gateway enforces the Swagger security types for its authorization enforcement. For the API key, there's two things that it can enforce: the client ID and the client secret. They have fixed values. For the query parameters, it's client underscore ID and client underscore secret. For headers, it's the user or the custom defined XIBM client ID, XIBM client secret. Those are currently fixed. That might change in the future. But for now, if you use anything besides those names, they won't work. Basic authentication, I'm not going to talk about that a whole lot because the next presentation is going to go into detail on that. And for OAuth, in the current implementation of Micro Gateway, we do not support OAuth 2, so if there's any OAuth 2 requests that come through, they're automatically denied. And that will probably change in the future. And that's a difference between the Micro Gateway and the Data Power Edge Gateway. Okay, next slide, please. So here's the API designer design view for security definitions. Like I said before, the parameter names, this is for headers, the parameter names are fixed. The names, you can type in whatever you want, but this is how you would set up the security definitions. And this is for API key. Next slide. And this is the design view for the security requirements. Basically what it does is it gives you a list of all your security definitions, and you just either select them or unselect them depending on what you want to enforce. And in the current release of API Manager or API Connect, there's a discrepancy between what's available through the UI and what's available through the Swagger document itself. The UI only supports a single security requirement, whereas the Swagger specification allows multiple security requirements to be defined, and so that one or more can be enforced. If you want to do that, you can't use the UI. You have to use the source view. So next slide, please. And here's an example of that. What I've done here is, in addition to the two API keys that I had defined before, if you notice on line 853, I defined a basic auth security definition. And on line 869, you can see that I've added it to the security requirements. And the way the security requirements work in Swagger is it's basically an array of security requirements. So the fact that basic auth is in its own array element means that its enforcement is independent of the other array elements. In other words, independent of the client ID and client secret. So the way that it would work is you would, if a request come in, it would have to match either the ID header and the ID and secret headers, or it could match the basic auth. If either of those pass, then the request would be let through. And so on line 869, if that little dash before basic auth was missing, that would basically mean it's part of the overall of the same security requirement as the client ID and client secret. And that would mean all three would have to pass. It's a subtle difference, but if you want more information, look at the Swagger specification. Okay, next slide. So with the previous security requirement, here's a curl command that you could use to actually get it through. Since it was defining the client ID and client secret through headers, you just use a -H to specify whatever your defined client ID and client secret is. And the actual client ID and client secret values, they're stored in the subscription models. The secret is stored in a base 64 encoded SHA-256 hashed version. You can see in the red block there what a client ID and client secret actually look like. And the developer toolkit, by default, it gives the values of the ID of default, and secret is secret in all caps. And that corresponds to the curl command up at the top. So
Dan, let me just add something quick. So if you're playing with the developer toolkit, as he described, there's a default client ID and a default secret. We don't have different subscribers, and so we wanted to kind of a hard-coded version that people could test with. So that's why we have the client ID of default and client ID of client secret of secret, just so that you can test. Sorry for the interruption, Dan.
No, that's fine. That's all I had.
All right. Thank you, Dan. Any questions for Dan on kind of general security or client ID and client secret? If not, let's go ahead. Thank you, Dan.
So just a confirmation. I saw on the two slides, one said OAuth 2, and there's the 4 grant types, and then the second slide saying OAuth 2 is not supported. So can you please clarify?
So in the definitions, you can just define your OAuth 2 security requirements, and you can even include them in your Swagger document, in the security requirements. It's just that on the micro gateway, they're not going to be enforced because we don't support it. So if any OAuth 2 requests come in, they're just going to fail the authorization.
Yeah, so Dan was going through what the Swagger document allows, but the microgateway does not support OAuth 2
right.
at this time.
And the thing you have to understand is that the UI is shared with the Edge gateway, which does support OAuth 2. So if in theory you could use the same Swagger document for either one, but if you're using it under the microgateway, then the OAuth 2 is just going to fail a request.
Okay, thanks.
Other questions? All right, thank you, Dan.
Well, there's one more. I'm sorry, we have one more question.
Okay.
You mentioned that the Swagger 2.0 supports OAuth 2. So let's assume that the customer is like OAuth requirement. Can we just define OAuth and the micro gateway will support that? No?
Are you asking if we'll support it at some point in the future?
Or are you asking if it supports the original OAuth versus OAuth 2? It doesn't.
Original OAuth, yeah.
Yeah, it doesn't support either one.
All right, thanks.
All right. Let's go ahead. So next up,
sorry, I have one additional question on that. Sorry, I was trying to get in.
Okay.
When we generate the Swagger that we're going to send up to the managed environment, that actually runs the data power gateways, are we saying that once it gets up there, those hard-coded client ID and client secret IDs must be changed?
Well, normally in a production environment, you would have your own subscription that defines the values that you want. So yes, you would definitely want to change those and not leave.
Well,
right,
it's just in the request itself. So if you're running on the toolkit, then that client ID with the ID of default and the secret of secret will be allowed through. But if you were running that same Swagger on a data power appliance, then you would have all of the real client IDs and client secrets, and they would be validated against the APIM database.
Right, and we just have to make sure that, if we have API creators working in their locals, we have to make sure that they either regenerate, change their keys out, or make sure that that they're using real keys. Otherwise, they're going to get errors. That's all I'm trying to get to.
Yeah, I don't think that applies here. I don't think that applies here because when you're in the toolkit environment, you're going to be creating the APIs and possibly even the plans and publishing them, but you're not really publishing subscriptions. And so you really don't. I mean, if you're in the toolkit environment, you're going to use that secret equals secret, and you're going to use the client ID as of default. And yeah, definitely you don't want to be using that in production. It's going to fail.
Right. Okay. That was what I wanted to make sure of, was that there was an actual check to make sure that teams didn't stumble over that. Okay. Thanks.
All right. Next up is John Balessa. John, are you on?
Yeah. Can you hear me?
Yes, we hear you fine. Go ahead.
Okay. Actually, it looks like the formatting is a little messed up. Do you want to go ahead and just share my screen? Is that possible?
Let me back out.
Oh, sorry.
You need to raise your hand, and then John can.
Yeah, I'll make you presenter.
Or Michael can. Sorry.
Okay. All right. Thank you.
All right, John, you are a presenter now.
Okay. All right. Is it shown on my screen here?
No, it's. Did you click the start sharing button?
There we go. All right. I think I got that.
Okay. I see something happening.
Okay. Cool. Yeah. All right. So for the basic authentication features here is basically just the typical username and password authentication that's found in just basic HTTP auth. So it essentially just requires that the users, the client supply a username and password encoded in base 64 and an authorization header. So it looks something like this, where it's authorization indicates that it's basic and then provides the base 64 encoding. And so I'm sure everyone here is probably aware of how this stuff works, but just worth mentioning that this doesn't actually provide any sort of secrecy, so it's always important to do this over TLS. So basically, what happens then once the micro gateway receives a request to an API that is supposed to be secured with basic auth, it looks in as prescribed in the security definition for the API. It looks in the request headers for this authorization header. If it doesn't find it, it immediately fails. But then if it does find it, it proceeds. And so the way that it goes forward in terms of actually authenticating, well, there are basically two methods for actually providing the authentication on the back end. So you can provide either with an authentication URL service, which is basically just more or less proxying an authentication request over HTTP or ideally HTTPS, or it could be secured with LDAP, which also LDAP over TLS is provided. So so the way that actually happens in the micro gateway is we basically look at the security definitions. Here's two examples of what they might look like. And basically we look and see, based on the authentication URL, we just look at the protocol prefix for the authentication URL to determine whether we're using LDAP or HTTP for the authentication URL. And then in the case of authentication URL, there'll be a TLS profile name available as a parameter on the authentication URL property. And then in LDAP, we have basically the same authentication URL property, provides the location of the LDAP server. And one thing I forgot to include on the slide here is, and Dan had it in his examples before, was an XIVM authentication registry property. And basically what that is doing is providing the name of the registry where the LDAP configuration is. So there's a lot of stuff that's basically missing from here that you would need to actually complete an LDAP transaction that's actually provided by the registry, and that's in the registry name, reference via a registry name and security definition. So just going a little deeper on the authentication URL, first, it's basically what it sounds like. It's just proxying incoming requests, just at least the authentication part. So it gets to this point in the authentication step, and it will basically send the same authentication or the authorization header in a new request to a backend authentication URL service. And if that comes back with a 200 OK, then the client is authenticated and the request can proceed through the processing on the micro gateway. Otherwise, if typically if the authentication fails, it'll be a 401 that we get in response from the authentication URL service, and so we would respond with a 401 in that case too. In general, if any error occurs in the authentication process, we respond to the client with the 401 just to maintain compatibility with Data Power's operations. So moving forward into LDAP, when doing LDAP authentication, we have several different methods. Just as a little bit of background on LDAP itself, it's basically a directory database. It's that allows basically user records to be identified with distinguished names, which is basically the unique name for a particular record. So there's several ways that we have of interacting with the backend LDAP server, which we call search DN, compose DN, or compose UPN. Search DN is basically if you're provided with the username, but you don't necessarily know all of the parts of the distinguished name. You can request that the LDAP server search through the records and provide you with the records that match. And then if a match is found, then you basically attempt to bind to the LDAP server with that distinguished name and the provided password. And that's basically the process of performing the authentication is more or less logging into the LDAP server with those credentials. So if the login attempt fails, then you say that the client failed to authenticate. Now, the next method is the compose DN. So in that case, you will be aware of how the full distinguished name is formed, and all that is missing ahead of time is the username. So you just simply fill in the blank and attempt to bind. So it's very straightforward. And then finally is compose UPN, and this is basically what Active Directory does, is how you would interact with Active Directory. And so, like I mentioned, it's similar to compose DN. So you basically will have a format that the UPN, which stands for it's I'm blanking on that. It's user. I can't remember off the top of my head what it stands for, but it's basically sort of specific to the Active Directory setup. And it doesn't actually form a valid DN, so there's some sort of it's sort of unique to Active Directory or setups based on it. But basically, you attempt to bind to a UPN with the provided credentials, and then if that bind is successful, then there's a further step of checking group membership to make sure that the credentials are valid for a particular naming context, is how it's referred to in Active Directory and LDAP. And so those are basically the three authentication methods for LDAP available, and those are basically configured within the LDAP configuration to correspond to how the backend LDAP server is expecting to perform the authentication. So that about does it on the basic auth. Were there any questions that you want to discuss on the air right now?
Yeah, there were a couple of questions on the in the meeting stream. The first one is mutual auth. Is it possible for LDAP-S?
Yes, I'm sorry. Yeah, basically the TLS profile name is provided in the LDAP configuration. So I'm assuming that's what you mean is can we verify authenticate the LDAP server, and that is the case. Yeah, you have the option of not doing that, but it is a capability that we have based on the TLS profile that would be referenced from within the LDAP configuration. Does that answer that question? Yeah,
let's go on to the next. I think you did answer it pretty well.
Okay. Okay.
Okay.
Yeah. Okay. So yeah, I'll move forward. And then regarding caching, there's not LDAP caching right now that can be added in without probably too much trouble. Anyway, moving forward to the cores section. cross-origin resource sharing. It basically is a way of allowing APIs to explicitly declare how basically external referral origins can access or invoke client requests on an API. So it allows the API to define what external, which of external origins may initiate a request by a client, the methods that they can call with cross-origin requests, and then which custom headers are allowed on those requests. And basically what's happening is it's selectively relaxing same origin policy, so that you can have a little more robust functionality. And just to clarify, an origin is specified by the protocol host and port that's being requested. So all three of those have to be the same in order to not run into CORS issues. But then if any one of those changes, then you start running into a CORS policy. So in CORS, there's this notion of pre-flighted requests. And that's basically where before you do a certain type of request, you have to make, the client will automatically issue another request with an options method. And this occurs whenever, one of the three following conditions is met. So any request with a custom HTTP header will invoke a pre-flight request. Any request that uses methods other than get, head, or post, or finally, any post request that has a non-standard content type, so specifically one that's not the encoded, a URL encoded form, a multi-part form data, or plain text. And one important thing to note is that all pre-flight requests occur without any authentication data, and basically occur before authentication takes place. So that's an important part about the architectural considerations here. And so basically what happens, the core of what we do for core support in the micro gateway is primarily about handling these pre-flight requests. Mainly because it has to happen before authentication occurs, which means that we can't just allow an options request through to the back end to allow the API that we're proxying to handle it, because it hasn't actually met authentication yet. So basically what we do is, by default, we enable core support for all APIs in the that we are proxying, although you can explicitly disable it. And the requests to CORS enabled APIs are handled as following. This applies to all of the requests. So if the API explicitly supports a request method, so any it could be get, post, or anything like that, basically not a pre-flight request, we'll go ahead and add default CORS headers to the pending response, and then continue processing that request. When the backend responds to the request that we've proxied, we'll add the response headers and overwrite any of the default headers that we've put. So that's just a clear baseline way of sticking this in. But the real trick is with pre-flight requests, if the API does not explicitly support the options request, then we will basically catch that and respond with the default CORS headers and stop processing immediately. And so on the right here, I've listed basically what those default headers are. And so they are sort of conditional based on what's provided by the request. So for instance, if the request provides an origin header, we'll actually add that as the allowed origin. Otherwise, if it doesn't provide that, we just say that it's a wildcard. Then the allowed headers, basically, if the request headers are from a pre-flight request and provide the allowed headers, we just add those. And then if not, we just respond with an empty string. Then we expose the following headers just from internal that might be relevant to the client various headers that might be allowed or provided. And then in the allow methods, those are those that are specified by the Swagger definition. So just those that we actually have support for proxying, in other words. And then finally, the allow credentials. Basically, if the allowed origin from the first header is the wildcard, then we don't allow credentials on that. But if it specifies a specific origin, then we do allow credentials. So that basically sums up the core support. Any other questions?
There was a general question. Are TLS profiles the same for DP and micro gateway?
I believe so. I believe that's the case. Yeah.
Thomas, what is your thought there? Are they the same or are they similar?
Yeah, we're actually pulling in the situations where we're supporting a TLS profile, we're actually pulling it from the API manager.
Okay.
So, but it is worthy to note that the TLS profiles are not supported in the developer experience.
Okay.
So my internet word just crashed on me, so I don't know. I tried to hand back control. I don't know if it worked though.
I think it did.
All right. Good
as soon as you stop sharing it, yeah. Okay. Yeah, Tim, you got it.
Okay.
It automatically crashes the box.
Yeah.
Yeah, that's a value-added feature.
Make sure you get out. All right. Thank you.
Thank you, John. Okay.
I did have a question with regard to after processing the basic authentication, does the header being stripped out from the request before it flowing out to the backend?
It's really a question for Dan Bott. Do the authentication headers get stripped out?
So it does, right?
I don't know.
Yeah.
Libra, do you know? I don't think they
actually,
do.
Ali or Libra may know, because in the invoke policy will makes the decision on whether that policy, whether that header gets included and what makes it to the back end.
So the current behavior is that every request, every header that comes in from the request, from the original request, they are going to be copied into message.headers. That's the context variable that we discussed earlier on. So everything from the request will be copied to there. And if there is no processing, say, for example, if after doing the basic authentication, it removes the basic auth header from message.headers, then it will remain there, and that will be, of course, propagate to the backend system.
So we think that it will be propagated unless you take some action, for example, in the JavaScript action to remove it, correct?
That's right. Yep.
Great. Thank you.
All right. Let's go on. Ali, well, actually, let me wait for a second. Michael, do you want to stop the recording and start another recording, or should we just continue?
No, press on. We're good.
Okay. Ali?
Yes, can you hear me?
Yes, I hear you, but I just got there. Can you see the screen?
Yes.
Yeah, if you
start?
could also, yeah, I'll need you to speak up just a tad so we can get it on the recording. Thank you.
Can you see that, Ali?
Yes.
Oops. Okay. Let's go ahead.
Okay. So now we are talking about the policies. In the assembly, policies are used to perform different tasks, and one of the most important policies is the invoke. The invoke policy is used to call an API server via HTTP or HTTPS. User can add and edit the invoke policy from the assembly UI. Check the screenshot in the right-hand side. There is only one policy in the assembly flow. By clicking the invoke policy, user can enter the information like target URL, the HTTP verb, timeout, and the basic authentication, and the TLS profile name for creating a secure connection with the API server. Next slide. The invoke policy writes the API request with the headers and body that are read from the two context variables, message body and message headers. Therefore, users should populate the body and headers that are going to be returned to the API server before execution of the invoke policy. When the API response returns, the invoke policy saves the header, body, status code, and reason phrase in the 4 context variables respectively. Body and headers are saved under the message. Code and reason are saved under the message.status by default. This data can be read or manipulated by any other policy that follows the invoke policy. If users don't like the API response to override the message body, they can specify some other context variable to store the response. Check the output property of the invoke policy in the YAML example. Next slide. If the API server requires the connection to be established over HTTPS, a TLS profile must be provided to the invoke policy. User can create their TLS profiles in the admin console. A TLS profile should contain information like the CS certificate of the API server, the TLS version, and the application's private key and certificate. Okay, next slide. We are going to talking about the conditional policy. An assembly flow may contain one or more policies. There are 2 conditional policies that can be used to do the conditional processing. One is the operation switch, and the other is the if policy. The operation switch can execute alternative policy assemblies based on the operation ID or the verb and path pair. With the operation switch, the assembly developer can explicitly specify the assemblies to be executed for different operations. However, the operation switch doesn't provide a default case. The if policy can execute a portion of assembly when a given condition is evaluated as true. A condition can be any valid JavaScript expression. Therefore, with the if policy, the assembly developers can test a context variable and execute one or more policies, if only if the condition is tested true. We need to note the if policy doesn't provide the else. Next slide. An assembly is a flow that contains policies, one after another. In a flow, there is no branches. So to support the conditional processing, operation switch is used here. In this example, you can see different policies are applied to different operations. For the operation of getting an account, an invoke and a JavaScript policy are executed. For the operation of creating an account, another invoke is executed. Next slide. Here's the YAML of the operation switch policy in the last page. First, what is an operation? Operations are defined in the Swagger document. See the Swagger document in the right-hand side. There are two operations. One is read account, and the other is create account. Operations are basically the combination of HTTP method and the endpoint. So user can refer to an operation by its operation ID or the pair of HTTP method and the endpoint. So check the example in the left-hand side. Two cases are found in the operation switch. One is for reading an existing account matched by the verb and past pair, and the other is creating a new account matched by the operation ID. When creating a new account, the basic authentication is required for the invoke policy, and after that, a JavaScript is executed for further processing. Next slide. When the operation switch can only support the conditional processing by operations, the if policy is more flexible in that any condition that can be written in JavaScript expression is supported. So when a given condition is fulfilled, the specified policy will be applied. This is an example that if policy is used for parameter checking, there are three if policies used in a flow in this assembly. The first is test whether the request header as quantity is a valid integer. If not, an invalid quantity error is thrown. If the quantity is valid, the other two if policies are tested, whether the quantity is bigger or smaller than 100, and then we can process the two cases with different JavaScript policies. Please note that the request headers are parsed and processed in the pre-flow, so the header names are already converted into lower cases, and the header values are stored in string values. So here we need to call the JavaScript function parseInt, and it's not a number to examine the lowercase s quantity as a number in the condition expression. Okay. Next slide. So from the previous example, we see that the policies may throw errors at runtime. Every error is an object with a required name and an optional message. For example, the invoke policy may throw a property error if the verb is not valid, or it may throw a connection error when the API server is not responding. Such errors can be handled in the cage section of the assembly by their names, or developers can just use the default case to catch any uncoded error. The execute assembly will not be resumed even after the catch assembly is finished. Next slide. User can add catch.
Oops, I went the wrong way, sorry.
Okay. Users can add catch cases as many as they like. In this example, we create only one case for handle both of the invalid quantity error and the insufficient stack. For these two errors, a JavaScript policy and a set variable policy are executed for handling the problems. In addition, there is also a default case to handle the other uncoded errors. it contains only one subvariable policy. Next slide.
A question there, Ellie. So there's a catch clause that's defined, and then there's also a default. What is the default versus the catch? Is that error handling?
Yes, they are error handling. So in this error handling section, you can add as many catch as you like, and you can have the optional default for any other uncoded errors.
I see. So the catches are for specific errors that you want to process, and the default is for anything else, any other error.
Yes.
Okay.
Yeah, I'm thinking maybe a name like catch-all versus default might be better here. This is me speaking, but it's just, default doesn't seem intuitive here.
All right. Let me just jot down.
So on this part, the catch phrase is for invalid quantity error and the insufficient stock. I understand that invalid quantity error is being explicitly specified in the flow. So where does that the insufficient stock? How did you know use that name?
Most different policies can throw different errors. For example, the invoke policy, it can throw property error or connection error. These two errors here, invalid quantity error and insufficient stock, they are thrown by a throw policy or JavaScript policy. They are special, so they are custom policy. With the throw policy, you can throw an error of a name you specify, a custom name. So you can see.
So if I might, so the JavaScript, one of these JavaScript policies could throw insufficient stock. So
yes.
you knew from writing that policy that was one of the errors that could be thrown. Does that make sense?
Yes.
Okay, it does. Okay, so is that just the name that we need to use in the catchphrase? Is that case sensitive? I guess it is.
I guess I'm not sure whether Chris Bygrave or any other folks from the API MUI side can answer that question. I recall there was a discussion like, for every policy, it actually has a YAML file defines the contract of the policy, and that contract also provides the definition about what errors the policy could be throwing. And UI actually used that definition to figure out, if user would like to catch that error, what are the errors are applicable over there. I remember there was a discussion over there, but I'm not sure whether it was implemented in the GA code or not.
Ellie, for the question, is it case sensitive, the name of the COT error?
Yes, it's case sensitive.
Okay.
Yeah, so I guess the thanks, Libra. I think so when you define a catchphrase, do you get a drop-down list selecting what error you want to catch, or you just type it in?
Ellie, do you know?
Yes, we have a drop-down list for most of the errors. However, for some custom errors, they are not in the drop-down list, so you have to type it yourself.
Okay.
For example, you can use a throw policy to throw a custom error of your own. So only you know the name of the custom error. So they will not be in the drop-down list.
Okay. All right.
Okay. Other questions?
So, Chris Bygrave, *1 should do it. Does that work for you?
Chris, did you want to weigh in?
Yes, it does. I was trying *6. That's what the doc said.
Chris, did you want to comment on the error names?
Yeah, there was conversations about the gateway policies clearly defining what errors they throw, but nothing was ever done on that, so I don't have that information available.
So if it's defined in the YAML defining that policy, then it would show up in the drop-down. Is that correct?
No, that was the conversation we were having, but nothing was ever decided on that, so I don't have any.
Yeah, that was postponed from V5 GA. Okay. So that's the intent post GA, but we didn't get to implement it. So in the drop-down, you should only have the hard-coded ones that we know that the current out-of-box policies provide, and you can enter any other ones by typing the names themselves.
And then I've got a piece of work on me for the UI so that it also puts any custom throws in the assembly flow in there as well, but I haven't got to that piece yet.
Okay. Thank you, Chris and William, for weighing in. Any other questions before we go on? All right, Allie, go ahead.
Next slide. Okay. In this YAML, two if policy are used for the parameter checking. The first one checks if the S quantity header is a valid number, and the other one checks if it is less than 10. If not, the last invoke policy will not be executed. Instead, the throw policies are executed to throw the custom errors, the invalid quantity and insufficient start. So you can see in the catch section, one case is added for these two errors. When they are told, the message body and message status are populated with the error details. So a 400 response will be returned to the client. As for the other errors, a 500 response will be returned. So that's all.
Any other questions for Allie?
Okay.
All right, thank you, Allie. Next up, we've got Gary Tu, who's going to take us through the set variable policy. Gary, are you on? Gary, you'll need to hit *1 to come off of mute. Gary still cannot hear you. Maybe we should come back to that section.
Can you hear me?
Gary, we hear you now. Yes.
Okay. The set variable policy actually is pretty straightforward. That it provides the capability to manipulate the context variable. For example, the message header, message body that that is presented previously by Ellie. And actually, there are three different type of action for this policy. That the first one that is you can set value to the context variable, and or you can append value to the variable. That the value of that variable will be converted to array if it is not array already. So that if
oh dear, I think we lost you again, Gary. Still there, Gary?
Can you hear me? Yeah, can you hear me?
Now we hear you.
Yes. There's some problem in my phone. It got to the serial mode.
Okay, we just heard you talk about the add action.
Yeah. Okay. It will append the value to an array, and or if there is if there already an object and that the value is not an array, that you will convert it to an array, and the existing value will be the first element, and the value added will be the last one. That is one. And the third action is that you can delete the variable from the context. That you can clear it. And the type of the value that you can assign is string, number, boolean, or integer. Or the other way to do that is you can put a string that as a placeholder, like $sign and variable within the parentheses. And the value of the placeholder will be replaced with the value of var for this example. Next slide, please. This one that present to you the example that how to use the set variable that you can, for example, that the first action that you can set message headers, text header, a value to the header, and the second that you can append a value to the same header, so that in the result that the message header dot x text header that will be array that with bus and throw. And the last action is clear. Header message dot headers dot x remove header. So this header will be removed from the header in the response. If you got the header from the backend, you can delete it in the set variable policy. I think that's it. Do you have any question for that?
Any questions on the set variable policy?
Yeah. So if the variable is already a array, can you set an entire new array value?
Yes. You cannot set in from the UI. Actually, you cannot set it the entire array. In UI, you can always set the primitive value, primitive type of value. But actually, if you have the custom JavaScript policy, you can set it in JavaScript in array.
Okay. Right.
Other questions? All right. Thank you, Gary.
Yeah, so there are some questions in the meeting stream, Tim.
Okay. Can you read them? I can't see them.
Sure. Shufan asks, can the value be a variable?
Can the value be a variable? So I think...
yeah, so I think you can do like these placeholders, like you see here, this $foo.bar, where you're effectively moving a value from one place to another.
Yes, you would replace with the value of foo.bar from the context of the concept about foo.bar. And if it is primitive value, it will be just copy. And if it is the value is an array, it will be a reference.
Okay. What else you got?
Yeah, so there's a, can you create a new variable? And
yes, when you call set or add, it will be, if the variable does not exist, it will be created.
Right. And it's important to note here that there's a set variable for the edge gateway as well, and the behavior should be uniform between the two. Is that correct?
Yes, it is uniform.
Other questions on the list, Thomas?
I don't see any. Yeah, I think we've got it covered.
All right, let's go ahead. Thank you, Gary and Thomas. Okay, let's go on. So next up is basic analytics, and to present that, we have Yi-Hong. Yi-Hong, are you on by chance?
Yes, Tim, can you hear me?
Yes, we hear you. Go ahead, Yi-Hong.
Okay. I think if you are familiar with the Edge Gateway, you all know that we have an activity log policy. But unfortunately, we don't have the activity log policy in Micro Gateway at this release. So we have some basic. We still need to support the API analytics features. So we implement some basic analytic functions here inside the micro gateways. So it is just gathering the basic statistics and send to the Elasticsearch servers. So here it's not a official policy yet. So you will see when Libra introduced the components of the micro gateway, you will see analytics middleware there. We implement the basic analytics right now as a middleware right now. So and so it's not a policy yet. So you are not able to drag and drop the analytic policy inside the editor right now. And it only publish submit the basic API usage to the Elasticsearch server so far. I think the activity log policy in the Edge Gateway support different level of the logins, but right now we only support the basic login in this release. And the important thing is this feature is only available in the management micro gateway, so it's not available in the desktop experience right now. So if you are using the developer toolkit, there will no analytics activity there. Okay, and so we do the implementation of the analytics in different mode. We publish the data in timer and batch mode, which means if the time hit, for example, 3 seconds, and within the 3 seconds there's only 3 transactions, and we will push these 3 transactions activity log to the Elasticsearch. Or if within the 3 seconds and there are, for example, like 50 transactions, and you hit the quotas of the upper bound, so we will submit these 50 transactions activity log at once to the Elasticsearch. So we implement the publishing timer and batch mode, and you will send to the URLI list here. And the API managers actually will be replaced at the runtime. And as I mentioned, it's a middleware right after the context creation. So every transaction after the context will be logged. And it is enabled by setting the API manager environment variable. So and this environment variable is only set in the management node. And currently, we are not able to partially turn on or turn off the basic analytic functions. So once you start micro gateway in the management node, then this feature is turned on, and you are not able to turn off it. But it only publishes the basic statistics. Okay, Tim, can we go to the next page?
Hold on, I got a question here. So here's what I got out of this slide here. So analytics are not enabled yet for the desktop experience. So in other words, it's not in GA.
No, it's not. It's not in the downloadable API Connect from NPM.
Okay.
If you are testing, you don't get analytics with that testing.
Okay. Do we have an expectation when we might see that?
So just a comment, and really it's a comment on the deployment. I think with the first fix back, the deployment for the micro gateway will be available, and that's when you should be able to use it. But it's only for the deployed micro gateway.
Okay. And so so below, it seems like we have to enable it by setting an environment variable. So is it I heard it mentioned this is on the management node. So this is not something we actually set on the environment where the micro gateway is running. So in other words, export API manager equals true or something. Or I guess I'm just trying to I'm confused about what that whole enable setting by that environment variable actually means.
Yihong, where is that environment variable set? Is it set for the micro gateway or somewhere else?
You mean the API manager environment variable?
Yep.
Okay. Are you talking about its value or when it's set?
Let's talk about both. First, where is it set? Is it set for the runtime of the micro gateway?
It's a runtime, so when you start a micro gateway, you will have several variables you have to assign before you start micro gateway in the management node. And this variable will be set when you start to run the micro gateway.
And
this variable will...
Yihong, let me interrupt there for a second. So that API manager environment variable is set automatically in the professional deployment, I believe, and is used for other things like extracting the APIM artifacts from the server.
Yes, correct.
So you're just saying that also has to be set for your analytics to work properly.
Yes. I should say the basic analytic middleware also use this variable, just like our data source middleware. I should say the data store, yeah.
So to answer your question,
to the CMD server.
Yes, so to answer your question, yes, it has to be set for analytics, but it's already set in the setup of the deployed micro gateway. So really, this is not an additional step.
Okay. Thanks. Yeah, I would have to assume once it's there, we'll see in the info center. So any requirements we'd need to enablement would be documented there.
Yep.
Right, and you have to consider that there's no API manager in like a developer experience. So there's really nobody to send analytics to. So it's really hard to support that.
Any other questions? Whoops. Why don't you go ahead, Yihong?
Yeah, I do have one I posted in the chat. So what is considered a basic API usage?
The basic here is just like I mentioned, if you are familiar with the activity log of the edge gateway, there are several levels that you can have in the activity log of the edge gateway. One is the activity, and the other is the header, and the other is the payload. So the basket here means we try to mimic the activity level of the log.
So we provide a subset of what you can get on data power.
Yes, it's just like if you drag and drop activity log in the edge gateway, and you select the log, the content. Actually, the property name is content, and the value you assign is activity, and it just have the same behavior.
Other questions?
So when
go ahead, Yihong.
Okay, so if we go to the next page, I think I list all the payloads that I submit to, I send to the Elasticsearch. So that's the basic statistic that we send for the analytics. And most of the value are retrieved from the context variables, except some of them like remote host, that's the client ID or host name, and byte receive, that's the raw bytes we receive from client, and byte send, that's the raw bytes we send to the client. And I think most of other value actually is are retrieved from the context variable. So you can get more detailed information from the context variable.
Okay, and so all of these properties are gathered for every transaction, is that correct?
Yes, that's correct.
Okay. Any other questions on the information obtained for the analytics? All right, let's go ahead.
Okay, so yes, JavaScript policy. I think you already heard about the JavaScript policy several times in early session, in debug sessions. So JavaScript policy actually is a handy policy that could be used to execute a JavaScript snippet. But it has some constraints. So the constraint here is that you are not able to use the required functions that we used in most of the Node programming language. So there is no require, so you are not able to require any third-party modules in these JavaScript policies. That's the first one constraint. And you can only access the ECMA 5.1 functions. And you are not able to allow to use any asynchronous functions in your code snippet. And you are not able to use the use strict declaration. So therefore, you are not able to use any block scope declarations as well, because you are not able to use the use strict. But what things you can do inside the JavaScript policy is that you can direct access all of the context variable inside your JavaScript code, just like Libra. Libra should put some example previous. So, and Ali also have some examples in his sessions. So you can access all the context variable directly inside your JavaScript code. And another thing is that you can use the console. We provide another console modules. You can use the console module to log the message, and those messages will go to the system log. Okay, I think can we go to the next page? Okay, so I think the big question will be what's the difference between JavaScript policy versus the user-defined policy. So just like I mentioned, because you are not able to use the required function for any third-party modules inside the JavaScript policies. So if you are doing anything very typical value checking or validations, you can use the JavaScript policy directly. If you remember the example of the if condition that Ali have, to try to check some quantity values, and she used the if condition to show different exceptions. Actually, you can do all of the if condition inside a single JavaScript policy directly. And you can, inside this JavaScript policy, you can directly check those context variable, check its quantity, its value or not, and you can directly show the exception directly. So you don't have to compose three if sections. You could just put a JavaScript policy there and contain those three different if checkings. So if you are trying to use some async functions, and you are also need to have some third-party module to complete some of the tasks that you need, then you have to create a user-defined policy for that. And I think Thomas will cover that later. So that's the difference between the JavaScript policy and the user-defined policies. So Can we go to the next page? Okay, here is just two simple JavaScript policies. You can see that JavaScript code actually is directly embedded inside the YAML file, the assembly. So it's just embedded as a string here. So all of your code will be embedded inside the assemblies. So the first example is you can just directly assign the request.order concept variable to a new context variable. So you compare the message.body.orders, it should be an array, and you compare those values with the common and reassign to the request.order context variable. That's the first example. And in the second example, we just try to check if the message.body.order quantity is a number or not. If it's not, it will show JavaScript error exception. I think that's all for the JavaScript policy.
I do have a question that I had forgotten back when Ali was presenting. If we throw an error object with a name and with a message,
yeah.
Can that message be accessed somewhere else? Can it be used to, for example, can you just log it?
Yes. Eddie, please keep me honest. I believe that let's throw the error object that is will be stored into the context the error as well. So you can use context the error to access the error object, and as well as the message.
I see. Cool.
Yeah.
Any questions for Yihong on the JavaScript policy? Let me just scan through this real quickly. Okay, so next up, we have Dan Bott again. Dan, are you still on? Thank you,
Still
Yihong.
Here.
All right, Dan, why don't you go ahead?
Okay. So logging for the micro gateway, basically by default, there's a default configuration, and then it's extensible to allow you to log differently into various places. Is this the first slide?
Sorry.
Yes. Okay. Okay. So yeah, this is the introductory slide. I'm going to just talk about, give an overview, how to configure it, where the output goes, and how it works with user-defined policies and JavaScript policies. So next. Okay. So logging in the micro gateway, it's implemented through the Bunion package, which is a Node.js thing. If you really want to understand how logging works in the micro gateway, it would probably be a good thing to look over and understand how Bunion is configured, unless you want to just do the default stuff, because it has a lot of flexibility in terms of what it logs and the formatting that it allows. So by default, we provide logging levels, fatal, error, warning, info, debug, and trace. And those are controlled by, as I'll show you in a bit, the names or the methods you use for the logger. It also allows for the creation of child loggers, so different components can be have their logging entries labeled so that they can be filtered out based on the component. So Bunion, its output to the log by default is JSON format, and the Bunion program itself can be used as a formatter to format it into a human-readable format. So if you're logging to a file, by default, it's logged in JSON. And Bunyan also provides for customizable streams for output, different files or standard out, whatever. And by default, logging is available to the APIC.log file, and I'll tell you in a minute where that is. Or there's a CLI command, APIC logs, which prints the output to the console. So next slide, please. Okay, so logging is controlled by a bunch of environment variables on the micro gateway. The first one, APIC config path, is more of a general environment variable that specifies where the logging configuration file itself is. Then there's APIC log config file, and that specifies a location. Besides the default log, you can also have a user-defined log. I'll talk about that in a second. And then there's these two other ones, APIC log console level and file level, and that controls through an environment variable the lowest level that will be output to a file or to the console. For example, so if you set it to like debug, that'll log debug and above, so info, error, warning, all those other ones. If you wanted a little bit more sparse, you would set it to error, and that would only log the error and above. So there's three sources of configuration, and there's a precedence to them. You're allowed to define a user-defined log configuration file, and that can be either JSON or JavaScript. I'll show that in a second. The JSON, if you have both files, the JSON takes precedence over the JavaScript. Then there's a system log file, and that's configured through the APIC config path that I described above. And so there's also the built-in configuration, and like I said, there's two places it'll log the console. Default is warning. That can be overridden, and the stream is to the file, the APIC.log file, and that's unformatted. It has a set file 1-day rotation and default level of info.
Dan, how big are these files?
Currently, they can get arbitrarily large. We're about to implement something that will set a maximum, but in the GA version, we don't have that yet. So you have to keep an eye on it. So next slide. Okay, so here's some example configuration files. On the left is the JavaScript version. On the right is the JSON version. So the JavaScript version basically is just a small JavaScript program that exports this JSON. And what the JavaScript allows you to do is to do some things programmatically, whereas the JSON version is more of a hard-coded. So you'll notice, for example, the path in the JavaScript version, you can specify a path based on your current home directory, whereas in the JSON version, that has to be hard-coded. So this is actually the default file configuration, I guess, except for the level. The level's not debugged, but and all these fields are just Bunyan type configuration. If you look under the Bunyan package, you'll see what all these things mean and how to configure them. So the next slide. And here's some examples of output. The first one is the raw JSON that's sent to the APIC.log file. If you just count the file, this is not very human readable, but if you're going to process it programmatically, it's very convenient to use that. And you'll notice the LOC field in there. That is, I was talking about child loggers. That's the string that's associated with a child logger. The second one is the APIC.log formatted through the Bunion program, and you can see that's a more typical human-readable format. And then the third one is the CLI command APIC.logs, and that outputs a more compact version, and that goes to the console by default. It tails. If you do, I think it's -N, it will not tail. And next slide. So logging in the user-defined and JavaScript policies, kind of already went over this, but if you define your own policies, you can log to the system logger. The Bunion logger object is basically passed in to the flow engine object. That's a parameter to the function. And you can use all the standard methods. There's an example one down there, logger.info. You could say logger.debug, logger.trace, logger.error, and it'll go to the various levels. And yeah, so it'll go to both the APIC.log file or the APIC.log CLI command or any other stream that you have configured through the configuration file. And I think that's all I had.
All right. Any questions for Dan on logging? All right. We've got a couple more modules left. Next up, Thomas, are you still on?
I'm still here.
You want me to flip the charts, or do you want to control?
I'd like for you to flip them, please.
Okay. Go ahead.
Okay, so user-defined policy, I almost feel like I don't need to talk about it anymore because so many people before have done a lot of coverage on this. But, I'll just sort of take you through the details here. User-defined policy is basically a node module, and it's, you're only basically limited by your imagination as to what you can do. You can require other node modules, that are out there in the community. You can, do, sort of whatever JavaScript level or ECMAScript level that you're, running your gateway on. You can use, utilize it to whatever extent you see fit. So we don't put any limitations on, ECMAScript 5 specifically. We don't even know what you have in your policy, basically. But you're allowed to do JavaScript code, and we give you the hooks into API management that you need to be able to pass properties and whatnot dynamically to your policy. Just like you would with a data power policy. So, we haven't really invented anything beyond what you can do with data power policies. And so for those of you that have done a user-defined policy, on an edge gateway, in previous releases, a lot of this will be familiar with you, for you. And so the first thing I'd like to cover is, what does a user-defined policy look like, like when you're developing it? And so, as I already mentioned, it's an NPM module, and so it has a package.json, which is sort of the center of the universe when it comes to NPM modules. The package.json points to where your main JS is, and in this case, I just happened to put my main JS under a lib directory and called it index.js. That's pretty conventional. So this But you know, this is the index.js in this particular example would contain the entire implementation because that's the only JS file that there is there. You're allowed to stick other stuff into the into this directory that your policy is implemented in, like the readme.md. You know, you can have a travis.yaml and that sort of thing. You know, we're just basically going to ignore it as far as the micro gateway is concerned. But you know, there are some conventions that the community has that that we're just going to let you do the same things. And so the piece that wouldn't be familiar to a Node developer would be this policy.yaml file. And you know, we've got some flexibility as to what you can call this. You know, it can be policy.yml, policy.yaml, and there may be some decision to change this in the future. But right now, it's got to have one of those two names. And the convention is to do YAML as sort of a best practice in this case. Excuse me. This started right when it was my turn to talk. So I think I'm done with this slide, Tim, if you would fast forward it to the next one. So I just talked about the policy.yaml. Let me give you a little more deep dive on this. The policy.yaml is going to stick with the schema that's already been defined for the 4.x version of for API Manager, right? So I've got a link on this slide that takes you there. It shows you all the different types that are available, like integer, number, string, Boolean array, and so so this is we're basically we have the same support for that. Some key differences that you'll see with a policy YAML that the 4. I think 3 is where it was introduced. The 4.3 product would have is that in this case it's actually called policy.yaml. It's not named after the file. It's not named after your policy name, which is the convention for 4.3 and beyond, or 4.03. And also, you don't need to have the attach field in your policy.yaml because it doesn't really apply for a micro gateway. The whole notion of attach REST or attach SOAP, it doesn't apply here. And also you must include a gateways field to your policy.yaml. And I've given an example to this, gateways, micro gateway. You could also have, this is what you see here where it says gateways and there's a dash micro gateway. That's a representation of, I think they call it a scalar, but it's basically an array. And so you could have micro gateway and data power gateway as, so you can have one policy that supports both. I don't really see people doing that too much initially, but it may be something that picks up over time. So, but you can do that. But it is required because the UI uses that as a hint to place this policy onto a palette for you to be able to drag over to your assembly. Next slide, Tim. Okay, so now we're going to get to the meat of the policy, the actual implementation. Again, I'll just remind you this is running under Node.js, and we've defined a pretty simple interface for the policy. You've got module exports, which basically tells the flow engine how to get to the meat and potatoes of your policy. You can pass in a config object. We haven't really gone through and done a lot of documentation of how to use this config that's specified here. And this is a sort of a setup once config. It is used by our rate limit policy to determine whether we're going to use Redis or a token bucket, a simple token bucket algorithm. At runtime, you can actually pass config into the policy as you're instantiating it. But the data power gateway doesn't have support for this, so we're sort of keeping it close to our vest right now. And but we will, once we elaborate this into the policy YAML and to the definition, then we're probably going to show how do we set this on a broader scale and have support in the UI for it. So that's what that config is. It can be empty. As a matter of fact, I think it'll typically be empty. It'll be an empty JSON string, an empty JSON array. And the actual implementation, the runtime enforcement, is handled by this return function, and you've got props context flow. You saw this earlier today, where you have the props. The props is a JSON object that contains the configuration that was set for this policy in the assembly. So, when you drag a policy over to the assembly, you get the opportunity to fill in some values that you've defined in your policy YAML, and those values get basically, bundled into the assembly flow in the Swagger document, our extension to the Swagger document that gets passed down to the runtime. And then once you actually get to enforcing your policy, your properties that were defined and set in the assembly UI get passed in that properties variable right there. You also have access to the context, and the context is sort of the center of the stuff that you want to work with. That's how you get to your headers. That's how you get to your message body. That's how you get to, what's the third thing? Variables, context variables. All that is sitting in context. And then flow is an object that contains some helper methods that you need to be able to properly go through the like proceed to the next policy or do so. It'll contain a logger, and it'll there's some other stuff that I'll cover a little bit later. Okay, so Tim, next slide. Okay, so I just went through what these are. I guess I don't need to read it off to you again. But again, this is the config, which is, we mentioned, we talk about, but we don't do too much about documenting it right now because we're still refining how we want to present that to customers. Then the props context flow or the other parameters. So, Tim, I should have asked you to advance before we got to this one, but thank you.
Sure.
Okay, so the flow parameter, as I'd mentioned earlier, definitely is worthy of a little more deeper dive on what you can do with it. You saw the flow.proceed in the example that we had shown. That's basically returning control back to the flow engine, so it can take you to the next policy in the chain, or return back to the client. You can also say that hey, whatever I've been doing in code, I fail. And so you can fail and give it a reason, and then the flow engine will try to handle it, and if it can't handle the error, then it'll return back to the client. You can also call stop, which basically says, hey, I'm the last guy in the chain. I don't care if other policies are defined, in the assembly. You shouldn't go any farther. There's a bunion logger. You heard Dan talk about that, and he gave a lot of detail on how to set, where does stuff get logged and whatnot, what error level does it get logged. And Tim, next slide, please.
Can I ask you a question there?
Sure.
So the error that you pass, the error object that you pass to the fail method, is that the standard exception? Does it have a name and a message? And will it show up as a thrown error?
That's a good question, and I can't answer that, but I know we've got people on the call that can. So, Libra?
See if Yihong is still on. Yihong, are you still there? Or Ali? Yihong, are you there? Libra, any thoughts?
What was the question?
Okay, so the question is the fail method on the flow object. If you pass it an error object, is that the same as throwing an error? Will it be caught by somebody looking for that name?
Yes, it's like throw an error. So
go ahead, Ali.
So the error object must have name and message, optional message.
Okay. and it will be handled just as though it was thrown. Correct? Okay, so let me just make the statement, and Allie, keep me honest. So this is a thrown error, and it can be caught just like any other error in the system. Is that correct?
Yes.
Okay.
Cool. Okay, so Tim, that's a great question, and I'm going to write it down, and we probably need to document the format of that error object that gets placed into there.
Cool. Okay. Sorry for the interruption.
Oh, no problem. This is a good question. Okay. So it's some additional stuff that you can get from the flow object is the ability to subscribe to events, and these are policy enforcement related events. And so you can do things like I want to subscribe to when a particular policy has finished, or basically actually when the transaction is finished, or if before or after some other policy has been enforced. And so there are certain things that are done in the Edge gateway that sort of required a lot of hands-on manipulation by the actual enforcement framework for things like the analytics and redaction and stuff like that. And so this support to be able to subscribe to like when a transaction is finished and that sort of thing, it gives us the ability to do the same sort of thing without actually having to bake the help into the enforcement. And the antithesis of subscribing to something would be to unsubscribe something. So you can subscribe and unsubscribe events related to policies and to the enforcement of a flow. Okay, Tim, I'm done with that slide. Next one, please.
Hey, Thomas, I think there is a question on the discussion whether the user-defined policy is available on Data Power or not.
User-defined policies are available on the Data Power Gateway, but not ones that run Node. So the Data Power Gateway has supported user policy since I think 4.0.3.0, and but it's strictly a Data Power implementation. So you actually have to create a processing rule and pull your Data Power processing actions onto that rule, and you have a certain API that you need to call to get your properties and to get your the payload and that sort of thing. And it does depart from the way this, or actually I should say this departs from the way that you would do it on the Data Power implementation, because we wanted this to be a lot more accessible to the Node community, so that when you have a Node developer sit down and create a user-defined policy for the micro gateway, they're in familiar territory. They know exactly what to do, and they just add another file and do a couple of other things, and it's a happy place for them. And so I think I go into some packaging or deploying. Okay, so I've got some deploy slides as to what these look like, and what I can do is I can talk to the differences between the Data Power experience and the micro gateway experience as I'm going through these next few slides. And as I'd mentioned earlier, you can actually create a single policy with Data Power implementation and a micro gateway implementation. But there are some limitations in this release as to how we can handle that sort of thing, and I'll try to highlight those as I proceed. Okay, so in the offline experience, also known as the developer experience or the laptop experience, you can actually, once you've created your policy, you can actually go off and and test your policy in the offline experience. And to do that, you pick a place to put your policy. Like in this case, I put it in my home directory. I created a directory called My Policies, and I stuck my cool policy under there. Now that's a directory, and it would contain the package JSON, the policy YAML, and the implementation and whatever node type of stuff I wanted to put in there. And then one thing that's actually missing from here is that there's a step that you would run right after that. Once you put it in that directory, you would actually run npm install to resolve whatever dependencies that you've got in your particular package, because the micro gateway doesn't handle the dependency resolution. It can't go out to the internet to say, oh, I'm using Lodash or that sort of thing. So you need to make sure you resolve those dependencies, and then you can go in and update the either your .api connect file in your home directory, or the .api connect file in your home directory, or in your that's actually wrong. There's a .api connect directory with a config file in it. Tim, I need to edit this at some point. Or there's a project that you're running. If you're doing your typical laptop experience, you would have created a project, and then there's a .api connect file in there, and you add the directory that would contain your API connect policies. And in this case, I've got another inconsistency. I've pointed to an API connect policy instead of my policies. So I apologize for the inconsistencies on this slide. But you point to it with a YAML addition to these either the config file or the .api connect file. And then when you bring up the APIC editor, it'll go off and find your policies based on the contents of this directory. And then when you run traffic through the micro gateway, it's able to find the policies as well. So it's important for this to show up in your assembly editor on your UI experience, but it's also important for the micro gateway to go off and find these. And so sans all the typos on this particular slide, this is how you set it up. Tim, next slide, please. And offline experience, looks like this might be the same information again.
Only larger.
Exactly. Okay, so this would have, would have been good to review after a full night's rest.
Next chart?
Yeah, next chart.
That's the last one.
Okay, so I know what happened here. I think that I might have pushed the wrong file up. So, Tim, flip back to the offline experience again. This was supposed to be the online experience, and so I'll talk a minute here about packaging for the offline experience, the online experience. The data power, when you create a policy for data power, there's a zip file that contains the policy definition. So it's essentially your policy YAML. And then there's a directory called implementation that would contain your data power implementation. It's basically an export or a zip containing your exported configuration for data power. And it's in a zip as a convenience, because that's how data power moves, how you can move configuration from one data power appliance to the next pretty easily. And that zip contains your processing rules or your configuration describing your processing rules, your whatever XSLT or gateway script files that you have, and the processing actions and that sort of thing. And so there's already an established convention for that. And so in that same implementation directory, you can take the contents of your node.js implementation and zip it up and put it in the directory, the same implementation directory as a policy name.mgw file. And I think Stephen Cox is actually talking a little bit about this on the meeting stream on the side here. And so you place that there, but you also have to realize that you need to update your policy YAML. Let's say if you're adding micro gateway policy to a data power policy, you have to update your gateways. You have to add the gateways property to the policy YAML to tell the UI that this is effective for the micro gateway. And in fact, there's a bug open on the implementation right now that you have to specify data power gateway to get it to work, to import properly. You have to have the gateway's keyword for now, but I think that bug will be fixed soon. The story doesn't stop there. So that just gets it to where the policy shows up on the UI in the API manager. But there's no we haven't architected the flow all the way out to like deploying a policy yet, like it would on data power. So as soon as you import a policy, a data power-based policy, into the API manager, it takes that policy and manipulates it and pushes it out to the data power appliance. But there's no flow like that to send the policy out to the micro gateway yet. And so there's another manual step that when you're running in a micro gateway in the online experience, you'll have to place the policies into a location, point to them just like I'd mentioned for the offline experience, and then you'll have to do the npm install to resolve the dependencies, and then you bundle up the gateway as part of the instructions for deploying the gateway, and basically deploying them through either a Liberty Collective or through the like a standalone. Actually, you won't need to deploy it in a standalone gateway mode, like for the essentials. Okay, sorry that this last slide was a goof, and I had to pretty much talk through the whole thing, but we'll get updated slides out.
Yeah, actually, I was going to say, Tim, if you could, you mentioned a couple of adjustments to this deck. If you can go ahead and do that and get that over to me when you can, then I'll get this published out along with the video for this session onto the media library where the other ones are posted.
We will do so, and I was also thinking perhaps in the second session maybe we just briefly cover some of the user-defined stuff if there are differences. Okay. Anything else, Thomas?
No, I'm pretty much out of breath, so yes, we can go to the next presentation.
And anybody else have questions for Thomas on the user-defined policies?
So Tim, is there more? I think we're at time. I thought we had a 7 to 9:30 slot. Is there more to cover?
There is. There's one additional section. John Palgon, are you on?
Yes. Mike, do you want to continue, or?
How much longer do you have?
Maybe 10 minutes.
Yeah, go ahead. Just get done.
All right. So the data store is the component. If you recall the diagram or picture that Libra mentioned at the beginning of the presentation, it was the component all the way to the right. It's responsible. It's kind of like the micro gateways database containing all the relevant information about what the micro gateway should actually enforce. So the data store itself is actually a loopback application that contains all this information. The micro gateway is responsible for starting the data store. So as Tim mentioned early on, they kind of go hand in hand. Micro gateway currently, for each micro gateway instance, you have a data store instance. So they're meant to run on the same system. Maybe understanding what the data store is will go to answer Dinesh's question from early on about whether this is, realistic to deploy in the DMZ. The only user of the data store in reality should be the micro gateway. And if you need to extend the micro gateway, the facilities for accessing information in the data store are in that directory data store client index.js. There's a few a few methods that somebody could utilize to call the data store, to query information in the data store. So the data store, being an application, it actually listens on the loopback IP address on a specified port for HTTP requests. So by default, if you don't specify the data store _port environment variable, then it'll just listen on an ephemeral port, which should be fine for pretty much every deployment. It's just for debuggability, it's nice to be able to specify a specific port to listen on. And here's the warnings, and this I mentioned this may be a reason to not deploy in the DMZ. So it's not currently, this loopback application is not currently protected by an access control list, so there's no type of user that needs to access this information. It's basically whoever is able to access this port and send HTTP requests to it can access it. It's not HTTPS protected, so it's just HTTP. So the information that's going back and forth, although it's happening over the loopback interface, is in the clear. There's actually more methods. Since we exposed it using, or developed this application using loopback, we kind of left a lot of the defaults, including a lot of the default methods, that REST methods that are exposed when creating a loopback application. So right now there's actually more methods than should really be exposed. In reality, all that should be exposed are GET-type methods, and updating shouldn't happen. Updating of information shouldn't be allowed by the data store. And another warning, the Loopback Explorer is enabled by default. So if, in case you knew what ephemeral port the data store was listening on, you could actually hit that with your browser and view the information in this Loopback application. So if you click next, please, Tim, you'll see what the models are, the models for the data store. API store the Open API or Swagger documents. Catalog, product, registry, subscription, and TLS profile, those are all artifacts of API management. There's a few that are interesting. Webhook is unused. Snapshot is what we use. It's a mechanism we use to keep track of the latest configuration. And optimized data is what happens is we actually, when we gather up information, either from the file system or from API management, we create a separate model that's optimized for runtime lookup. Because if we had to query each one of these models for the relevant information at runtime, it would get pretty slow. So we create once information gets updated, either in API or product or subscription, we actually go ahead and process that information and populate the optimized data model, and that's the one that the micro gateway uses majority of the time at runtime. And click on the next slide. So just two more slides here. The development environment or offline experience, what happens, so when the micro gateway starts the data store will look in the relevant directory, load all the YAML documents, assume that they're APIs, that they're really Swagger documents, and that'll populate the API model, and then from there it'll in order for the micro gateway to work, it needs a product catalog. It needs some information in the product catalog and subscription models. So it just populates them with some default information just to make sure that things work. And just so that you can utilize rate limiting, there's a laptop_rate limit environment variable that defaults to 100 per hour. That's available for testing rate limiting. And then the last slide is on the on-premise environment behavior. And the way we developed the data store, it really had to meet a few requirements that were essential to API management. One, it made sure that in the event it's unable to contact API management server for the latest and greatest information, you still want your gateway instance to be up and running. So it ensures that it always has validated use by persisting the information to disk when it downloads information from API management server. It persists that information such that in the event it's unable to reach API management server, it still has that persisted information that it can use. It periodically pulls API management server for information for updates. It does it on a 15-minute interval. You can change that, although it's not recommended because if you pull it any faster, sure, you may get updates more frequently, but you'll also put additional load on the API management server. And then that other model that I mentioned, the snapshot model, that was created to address another requirement of API management, API Connect, in that the ability for somebody to create or modify APIs and publish them without impacting any of the other in-flight transactions or currently available APIs. So the snapshot mechanism makes sure that these in-flight transactions aren't impacted by any updates to existing configuration. And it really makes sure that there's no delays or latency that occurs while processing new configuration. So new configuration won't be made available until it's completely been processed and the optimized data model has been completely populated. So if the data store discovers that there's new and updated information that it needs to process, it'll go and do that off to the side. In the meantime, existing transactions will continue to use the previous configuration until such a time that the new configuration is available, ready, and ready to be processed. There is a bit of protection of the information that's stored and kept on, as well as the communication between the micro gateway and the API management server, and that's protected by a key pair, and you can specify that information using the key name environment variable. And that was my 10 minutes.
Yeah, so John, I would like to make one sort of distinction. You've been talking about the on-prem scenario and how this works, but when you do it offline, the data store is still in effect, but it's only picked up at one point, right, when you start it up.
Right. So the refresh interval really only applies to the on-premise environment. The offline or development experience, it's picked up once when you start the gateway. If you update the, add a new OpenAPI YAML document or modify an existing one, if you want the gateway to see it, you need to restart the gateway.
Any questions for John? Other questions? I do have just a couple of comments to close with. Any questions? If not, let me just mention a couple of things. One is that the user-defined policies are listed as beta for this first release. And I think Thomas mentioned that there are plans to update update the interface as we go, so that's why it's listed as beta. A second thing I wanted to mention is a difference between JavaScript and gateway script. If you're doing a custom policy, the JavaScript really only allows you to access any modules, whereas gateway script only allows you to access the modules that Data Power has created and are available. There are some extensions you can do. You can create some modules of your own, but you don't have access as much access as you do with pure JavaScript in the user-defined policy on the micro-gateway. So there are some differences. There certainly is some level of overlap. If you just stick with the JavaScript language and you stick with context variables, then there are cases where you could have the same policy defined for both. Let me also mention there is no redact. We talked about some of the policy constructs, and I think it was mentioned the redact policy and perhaps the activity log policy. Those are not policies that we currently have in the micro-gateway in this first release. And last, I wanted to mention just a big thanks for the team for pulling together these charts. Libra, Dan, John Balesa, Ellie, Gary Yihong, and John Palgon. Thanks very much for pulling together the materials. And with that, I'll pass it back to you, Michael.
Great. Thanks, Tim. I really appreciate it. Good stuff here today. So just a quick note for folks on the phone. So we do have another T3 session here in about an hour, 15-minute time, a short follow-up to the analytics session that was started last week. With that, if there's no other questions, we'll go ahead and close this one out. Okay. Thanks, everybody.
Thank you. Bye.